So we're going to go over Chapter 7, Section 4. We're continuing with our logarithms. It's kind of what all of Chapter 7 is about. So we're going to look at properties of logarithms. So there's not a lot of math involved here. It's just knowing these properties and applying them. So we can condense logarithms if we had like one log plus another log, like it is here. We can condense it by multiplying the two things together, so m and n, and multiplying them together and just have one log there. So this is condensing our log. So if you had log base b of m plus log base b of n, since you're adding goes with multiplying to condense. If you were multiplying and the problem said to expand, then you would just break it up and add them. So you can go either way. But it's super important to know that multiplying goes with adding. Similarly, we can divide our logs and break it up by subtracting. So division goes with subtraction. And then anytime we have an exponent up here, we just take it and move it to the front to expand. If we were condensing it, we would take it from the front and move it up top. So you can put it either way. Usually in the question, if you see it up top, you know you're going to have to move it to the front. If the question gives it to you out front, you know you're going to have to move it to the top. So important here to know that multiplication goes with addition, and division goes with subtraction. So these are different concepts that you haven't seen before, so it's going to take some practice to get used to working with these, but the more you do it, the easier it'll become. So there's not a lot of math, it's just kind of moving things around. It's almost like a puzzle. So let's look at example 1a. What is each expression written as a single logarithm? So we're condensing this down to one log. So what did we say goes with subtraction? Division. So we're condensing our log into one. So we take the log and its base. So we have log base 4. That stays the same. And then we take everything behind it and divide it. So it would be 32 divided by 2. Yes. What's 32 divided by 2? 16.
What is this? What is this?
All right, and B. Again, we're condensing it to one logarithm. The first thing we want to do, if we have a number out front, we got to move it to the top and move it to the top. So this becomes log base 2 of x to the 6th power plus log base 2 of y to the 5th power. Now we're adding, so what goes with addition? Multiplication. So we just take our x to the 6th power and y to the 5th power and multiply them together. So we're going to have log base 2, because that just stays the same, and then we multiply x to the 6th power times y to the 5th power. And that's our answer. In the next two, we're expanding the logarithm. So if we look at A, we're dividing. What goes with division? Multiplication.
Subtraction.
Oh, subtraction. Division goes with subtraction. Yes, you're right, subtraction. So we have log 4x. We don't have a base here, so we just keep it log. So log 4x minus whatever's on the bottom, so log y. What's happening between this 4x, this 4 and the x? Multiplication. So we can expand it even more. What goes with multiplication? Nope. Nope.
Adding.
Adding. So we're going to add them. So log 4 plus log x minus log y. Every time you break it up and expand, you need to repeat that log each time. So it's not just log 4 plus x plus y. Every single time you break it up, it needs its own log. Log, log, log. Every single time you break it up, it needs its own log. This is our answer. All right. So we see we have division. What do we do when we are dividing?
Subtract.
Subtract. So log base 9, x to the power 4, minus log base 9, 729. What else can we do here?
Multiply.
Not multiply. We have this 4 up top. What should we do with that 4? Bring it to the front. So we have 4 log 9x minus log base 9, 729. And that's it. That's our answer. The whole goal here is, like, you're going to have your log with your base, but we just want one thing behind it and one thing behind it. So it's always going to just be like one term behind it. Sometimes it'll be a variable, sometimes it'll be a number. Like here we have just the 4 behind it, just the x behind it, just the y behind it. So we're splitting everything up so it's each individual thing has its own log. So next it says a logarithm with base 10 is called a common logarithm. If no base is written for a log, the base is assumed to be 10. So it's kind of like when we have the square root and we assume that our index is 2. Here, if we don't have anything written down here, that base is 10. Now what's special about the common logarithm, so when you have a base 10, is that your calculator can compute a common log. Like your calculator is stuck with log base 10 and it can't do any other log with a different base, which we'll get to that in a minute because there's a formula that we can do. But when you put like the log of 5 in your calculator, it automatically assumes that your base is 10. So your calculator can do common logs, but it can't do any other ones. So when we have a different base, we use this change of base formula, and this helps us put logs into our calculator. So we see we have the log base b of m. The m goes to the top, and the b goes to the bottom. So here it just says that we use this base of c now. We just made this new base c. We always call this base like 10, our common log, because if it's 10, we can put it in our calculator. It doesn't matter what that base is as long as it's the same thing. So c just has to be the same thing. So this would be log of m divided by log of b. And we can put each one of these into our calculator and divide. So this is our change of base formula to help us evaluate logs. So on our last slide, we're actually finding the value of these logs. So we have to use our change of base formula. So we're going to say log of what on top? What goes on top? You have two options. 27. Perfect. The bigger number, the one that's already kind of on top, goes on top. And then what goes on the bottom? Log of 81. So in our calculator, we can figure out what the log of 27 is. So we just click log 27. I think if you do it in the phone, you have to do it backwards. So you would do 27 and then log. We get 1.4313. And then we would do the log of 81. And we get 1.9084. And then we just divide these two values. So we would get 0.7499. Or 0.7499.
Can we
Oh, sorry.
round that to 0?
All right, let's look at B. So what goes on the top? Log 36. And what goes on the bottom? Log 5. And then we just put log 36 in our calculator. So we get 1.5563. And then we need to do the log of 5 in our calculator. We get 0.69897. And then we divide. So I got 2.2, we can round up here, so 2.23, if you just want to round to 2 decimal places.